Imagine a world where robots tend to our crops, planting seeds with precision and care. It's not science fiction, it's happening right now on farms across the globe. These smart planting robots are revolutionizing agriculture, and today, we're diving deep into how they're changing the game. Stick around to discover the future of farming. Smart planting robots are at the forefront of agricultural innovation, combining cutting-edge technology with traditional farming practices. These sophisticated machines are designed to handle one of the most crucial tasks in agriculture, planting seeds. But how exactly do they work? At their core, smart planting robots are equipped with advanced sensors, GPS technology, and artificial intelligence. They start by analyzing the soil conditions, including moisture levels, nutrient content, and pH balance. This data is then processed to determine the optimal planting depth and spacing for each seed. The robots move across fields with incredible precision, guided by GPS and computer vision systems. As they travel, they create furrows in the soil, drop seeds at predetermined intervals, and cover them with the right amount of soil. Some models can even apply fertilizer or pest control treatments simultaneously, maximizing efficiency. What sets these robots apart is their ability to adapt in real time. If they encounter obstacles or varying soil conditions, they can adjust their planting strategy on the fly. This level of adaptability ensures that each seed is given the best possible start, regardless of the field's inconsistencies. But these aren't just theoretical marvels. Smart planting robots are making a real impact on farms around the world. Let's look at some real-life case studies that showcase their effectiveness. In the heartland of America, a family-owned farm in Iowa has been using smart planting robots for the past 3 growing seasons. The farm, which primarily grows corn and soybeans, has reported a 15% increase in crop yield since implementing the technology. The precision planting has led to more uniform crop growth and reduced seed waste, translating to significant cost savings. Across the Atlantic, a large-scale wheat farm in France has integrated smart planting robots into their operations. The farm manager reports that the robots have allowed them to plant during optimal weather windows, even at night, leading to better germination rates and stronger early growth. They've also noticed a reduction in soil compaction, as the lightweight robots cause less damage than traditional heavy machinery. In a more specialized application, a vineyard in California has been using smart planting robots to establish new grapevines. The robot's precision has been crucial in maintaining the exact spacing and alignment required for efficient vineyard management. The vineyard owner estimates that the robots have cut planting time in half, while improving the consistency of the vine rows. These case studies highlight the versatility of smart planting robots across different crops and farming scales. But what are the broader benefits that make this technology so appealing to farmers? Efficiency is perhaps the most obvious advantage. Smart planting robots can work around the clock, covering large areas quickly and consistently. They don't tire, they don't need breaks, and they maintain the same level of precision throughout their operation. This increased efficiency allows farmers to optimize their planting windows, potentially extending the growing season and increasing overall productivity. Cost saving is another significant benefit. While the initial investment in smart planting robots can be substantial, the long-term savings are considerable. These robots reduce the need for manual labor, minimize seed waste through precise planting, and can lower fuel costs as they're often electric or highly fuel. Additionally, by optimizing seed placement and reducing overplanting, farmers can save on seed costs without sacrificing crop density. The impact on crop quality cannot be overstated. The precision offered by smart planting robots ensures that each seed is placed at the ideal depth and spacing for its specific needs. This leads to more uniform crop growth, better resource utilization, and ultimately, higher quality produce. The ability to tailor planting strategies to specific soil conditions within a single field can result in more consistent crop quality across the entire farm. Environmental benefits are also worth noting. Smart planting robots can reduce the use of chemicals by precisely applying treatments only where needed. Their lightweight design and electric options also mean less soil compaction and lower emissions compared to traditional farming equipment. As impressive as current smart planting robots are, the field of agri-robotics is continuously evolving. So, what's next for this groundbreaking technology? One exciting development is the integration of machine learning and AI. Future robots will be able to learn from each planting season, adjusting their strategies based on historical data and outcomes. This could lead to increasingly optimized planting patterns tailored to each farm's unique conditions. We're also likely to see more autonomous fleets of robots working in tandem. Imagine a team of planting robots coordinating with weeding and harvesting robots, all managed by a central AI system. This level of automation could dramatically increase farm efficiency and allow for 24/7 operations during critical periods. Biodiversity preservation is another area where smart planting robots could make a significant impact. Future models might be programmed to plant diverse crop varieties or even wild plant species alongside main crops. promoting ecosystem health and resilience. As climate change continues to affect agriculture, adaptability will be key. Smart planting robots of the future may be equipped with advanced weather prediction capabilities, allowing them to adjust planting schedules and strategies in response to changing climate patterns. Miniaturization is also on the horizon. Smaller, more agile robots could allow for precision, planting in challenging terrains or in densely planted areas like orchards and vineyards. The integration of smart planting robots with other emerging technologies, such as drone surveillance and IoT sensors, will create a more comprehensive and responsive farming ecosystem. This could lead to real-time adjustments in planting strategies based on up-to-the-minute data from across the farm. As we've seen, smart planting robots are not just a futuristic concept, they're already making a significant impact on farms worldwide, from increasing efficiency and reducing costs to improving crop quality and environmental sustainability. These technological marvels are reshaping agriculture as we know it. As the technology continues to evolve, we can expect even more innovative solutions to the challenges facing modern farming. The future of agriculture is here, and it's being planted by robots, one seed at a time. Imagine a world where robots tend to our crops, planting seeds with precision and care. It's not science fiction, it's happening right now on farms across the globe. These smart planting robots are revolutionizing agriculture, and today, we're diving deep into how they're changing the game. Stick around to discover the future of farming that's already here. Smart planting robots are at the forefront of agricultural innovation, combining cutting-edge technology with centuries-old farming practices. These sophisticated machines are designed to handle one of the most crucial tasks in agriculture, planting seeds. But how exactly do they work? Let's break it down. At their core, smart planting robots are equipped with advanced sensors, GPS technology, and artificial intelligence. These components work in harmony to ensure each seed is planted with incredible accuracy. The robots start by scanning the field, creating a detailed map of the terrain. This allows them to navigate even the most challenging landscapes, avoiding obstacles and optimizing their path. Once the mapping is complete, the robot gets to work. It uses its precision arms to create small holes in the soil at exactly the right depth and spacing for each specific crop. The seed dispensing system then drops a single seed into each hole, ensuring no waste and perfect placement. Some advanced models can even adjust the planting depth on the fly, accounting for variations in soil, moisture, and composition. But these robots aren't just about planting. Many are equipped with additional features that make them true agricultural Swiss Army knives. Some can apply fertilizer or pesticides simultaneously, while others collect soil samples for analysis. This multifunctionality makes them incredibly efficient, reducing the number of passes a farmer needs to make over a field. Now, let's look at some real-life case studies where these robots are making a significant impact. In California's Central Valley, a large-scale tomato farm has been using smart planting robots for the past 3 seasons. The farm manager reports a 15% increase in yield and a 20% reduction in water usage. The precision planting allowed for optimal spacing between plants, reducing competition for resources and improving overall crop health. In the wheat fields of Kansas, another success story unfolds. A family-owned farm introduced smart planting robots 2 years ago. They've seen a dramatic reduction in seed waste, cutting their seed costs by nearly 30%. Moreover, the uniform planting has resulted in a more even crop, making harvesting more efficient and reducing losses. Across the pond in the Netherlands, a tulip farm has embraced smart planting robots for their delicate bulbs. The precision of the robots has led to a 25% increase in flower quality, with more uniform blooms that fetch higher prices in the competitive flower market. The farm owner notes that the robots have also allowed them to expand their operation without increasing labor costs. These case studies highlight the tangible benefits of smart planting robots, but let's delve deeper into the advantages they offer. First and foremost is efficiency. These robots can work around the clock, planting vast areas in a fraction of the time it would take human workers. This speed is crucial during the short planting windows that many crops require. Cost saving is another significant benefit. While the initial investment in these robots can be substantial, the long-term savings are impressive. Reduced labor costs, lower seed waste, and more efficient use of resources like water and fertilizer all contribute to a healthier bottom line for farmers. The precision of smart planting robots also leads to improved crop quality. Uniform planting ensures that each plant has the optimal space and resources to grow, resulting in healthier crops and higher yields. This uniformity also makes harvesting more efficient, whether it's done by hand or with automated harvesters. Environmental benefits shouldn't be overlooked either. The precise application of seeds, fertilizers, and pesticides means less runoff and reduced environmental impact. Some smart planting robots are even designed to work with cover crops and no-till farming methods, promoting soil health and reducing erosion. So, what's next for agri-robotics? The future looks bright and filled with innovation. One exciting development is the integration of machine learning and AI. These technologies will allow robots to make real-time decisions based on vast amounts of data, adjusting their planting strategies to account for factors like weather patterns, soil conditions, and market demands. We're also seeing advancements in robot swarms. Instead of one large robot, farms might soon employ fleets of smaller, more agile robots that work together. This approach could offer even greater flexibility and efficiency, especially for smaller or irregularly shaped fields. Energy efficiency is another area of focus. Many companies are developing solar-powered robots or models with extended battery life, reducing the environmental impact and operating costs even further. Perhaps most excitingly, we're seeing the development of robots that can handle the entire growing cycle, from planting to monitoring crop health to harvesting. These all-in-one solutions could revolutionize farming as we know it. As we wrap up our exploration of smart planting robots, it's clear that they represent a significant leap forward in agricultural technology. They're not just tools, but partners in creating a more efficient, sustainable, and productive farming future. While challenges remain, such as the high initial costs and the need for technical expertise, the benefits are undeniable. For farmers, these robots offer a path to increased profitability and sustainability. For consumers, they promise higher quality produce and potentially lower food costs. And for the planet, they represent a way to feed a growing population while minimizing environmental impact. The agricultural revolution brought about by smart planting robots is just beginning. As technology continues to advance and these robots become more accessible, we can expect to see them become a common sight in fields around the world. It's an exciting time for agriculture, and these intelligent machines are leading the way to a smarter, more sustainable future of farming. The seeds of change have been planted, and the harvest promises to be bountiful.